Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable EC student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code ANKITESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay, so if you also dream the same thing, then join me in this journey on Unacademy subscription using the code ANKITESE. If you join plus subscription, you get all the top educators like me teaching you live in daily lectures along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code ANKITESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, up to now we have covered different types of devices that are used in analog electronics, op-amp circuits, BJT circuits, FET circuits, diode circuits. All these things we have covered. Now we come to one of the other topics which is not so relevant from GATE point of view and not in the GATE course, but it is in the ESE course by the name power amplifier. Okay, so first of all, this topic is based on BJT, so you can also study this topic directly after BJT amplifiers. Okay, otherwise you can keep it in the end because it is not so relevant from GATE point of view. Now in different devices such as BJT amplifier and FET amplifier, we have talked about multi-stage amplifier. Okay. So the figure on your screen also represents a multi-stage amplifier in which each stage has a gain of 100. Okay. Now sometimes the objective of a multi-stage amplifier might be to deliver high voltage to a large resistance, high voltage to large RL, low current, sorry, high current to low RL. But in both these cases, the power of the load VL square by RL or IL square RL will be low or moderate. It won't be high. Okay. But we make use of power amplifier in the output stage, which is mentioned as last stage. We make use of power amplifier in the last stage when we wish to deliver large power to the load. So what is meant by power amplifier? The amplifiers used in the last stage or the output stage to deliver large power to the load. A normal amplifier is not capable of handling a large amount of power, and that power is delivered by your power amplifier. Okay. Now the output resistance must be low. Why output resistance must be low? Because when we talk about the overall voltage gain, it is proportional to a factor of voltage division RL plus R0. If R0 is high, then AVS becomes low. Okay. And that is why we want to have a low output resistance so that a large amount of gain can be derived, or you can say maximum voltage appears at the load and there is less loss of voltage. See, when we talk about a voltage amplifier, then always there is a drop in R0. So if you want maximum amount of voltage to reach the load, you want to minimize the drop in R0. For that, R0 must be minimum. And that is why we make use of common ammeter configuration in power amplifier. Okay. Mostly we make use of common ammeter configuration, that is the BJT amplifier, as a power amplifier. Now when you are delivering a large amount of power, so we are handling large power. So our objective changes with the last stage. It is no longer restricted to gain, but at the same time I want to have a high efficiency or less loss. That is also an objective while designing a power amplifier, to have less amount of losses. Okay. Because at high power, if you have high amount of losses, then your efficiency will be very low, and large amount of losses can also lead to heating. Okay. It can also lead to heating problems. Is it fine? So that means one of the most important criteria when we are designing power amplifier is to talk about the efficiency or to talk about the losses. Okay. So how do we talk about efficiency? It is output AC power over input DC power. That is called as the conversion efficiency. That is amount of DC power taken from the biasing source and the amount of AC power delivered to the load. I have always told you, when we talk about an amplifier, it absorbs power from the DC sources used for biasing and then it delivers that power to the load. and that ratio will now be called as the conversion efficiency. Now see here, the input signal to the first amplifier is 1 microvolt. Due to 100 gain it becomes 100 microvolt. Then 100 gain 10 to the power 4 microvolt. Then 100 gain 10 to the power 6 microvolt, or you can say 1 volt. Then power amplifier makes it 100 volt. So at the first amplifier input was 1 microvolt, but at the last amplifier it is 1 volt. That means power amplifiers deal with the large input voltage, and hence they are called as large signal amplifier. So whatever models that we have studied so far in BJT, diode, FET, we have always called them small signal model. But now since the input signal to the amplifier is large, we have two cases. One is your small signal amplifier and the other is your large signal amplifier. So power amplifiers are always such that they have large input voltage and hence they are called as large signal amplifier. So what I have told you so far about power amplifier: power amplifiers handle large amount of voltage. Secondly, they handle large amount of power, and our objective is not just the voltage gain but it is also important to have efficiency as high as possible. So what are the differences between the two? Here it has small input voltage in the range microvolt. Here we have large input voltage greater than equal to 1 volt. Okay, small input and large input voltage. Now it only operates in linear region, or you can say active region. It operates in linear as well as non-linear region. It will operate in both the region. I will tell you the reason why it operates in both the region. What did we derive for small signal amplifier? Voltage gain, input resistance, output resistance, power gain, current gain, and phase shift. These were the parameters that we were interested in when we were discussing small signal model. Here we will have power conversion efficiency, which I am calling as eta. Okay, then output AC power, because this power will be used in computing efficiency. Output DC power, and then distortion, harmonic distortion. These harmonics will arise due to this non-linear region. Okay, that is why I am calling it as harmonic distortion. In small signal amplifier, we can analyze by two methods: mathematical, which we saw the circuit method in which we were designing the small signal model, as well as graphical method based on characteristics of BJT. But here we only have graphical analysis. There is no such circuit as the small signal model when we talk about the large signal amplifier. That means you only have to analyze the characteristics of the BJT and then only comment on the nature or comment on the output, but you can never draw a circuit to find the value of the output. Okay, and that is the case with large signal amplifier or power amplifier. Are you getting my point? Why we were always calling it as small signal amplifier? Because every time the input voltage was very low, but now input voltage is not low but it is high. So it is large signal amplifier. Next, let us talk about classification of power amplifier. Okay. Now first of all, as I have told you, what is the use of power amplifier? It is connected at output stage to deliver large power to the load. Okay, so it will deliver large power to the load and hence it is connected at the output stage. This large power can be used by load to drive other devices. Okay, it can also drive other devices using this large amount of power. Now what we do is we classify the amplifier based on their output or based on their amplifying range. Okay, that is, amplifier can vary from completely linear operation to completely non-linear. It can also lie in between, but we can have two extreme possibilities. That is, either the amplifier completely operates in the linear region or it completely operates in the non-linear region, but most of the amplifiers will switch between linear and non-linear region, that is for some amount of time in the linear and for other amount of time in the non-linear. Okay, so now we have what we will study in this chapter. We will study about class A amplifier. This is nothing but common emitter amplifier and it is completely operating in linear region. Okay, it is a linear amplifier. Then we have class B amplifier, class AB amplifier, which we will discuss on later on, class C amplifier. All these amplifiers vary in the operating point. Okay, we will vary the operating point. Up to now what we have said in BJT amplifier, that in order to use BJT as an amplifier we always have to bias it in the active region, but no longer we will say that. We will vary the operating point of the BJT and based on that operating point we will classify the amplifier into 4 categories. Okay, so the objective of this chapter is to understand these 4 categories, how to analyze and what are the crucial differences between all these type of amplifiers. Okay, now let us discuss about the distortion in the amplifier. What kind of distortions are present? So the first distortion is called as non-linear distortion. Now what happens if amplifier is completely linear? If amplifier is completely linear, in that case what will happen? In that case, for sinusoidal input we will have a sinusoidal output. Okay, there might be phase shift, like in common emitter amplifier we have a phase shift of 180 degree, but when amplifier is non-linear, then even after applying sinusoidal input we have non-sinusoidal output. The output will be periodic but it will be non-sinusoidal. If it is non-sinusoidal, it can be expanded in terms of Fourier series. Okay, so due to non-linear nature of the output, non-linear nature of the amplifier, the output becomes distorted, it becomes non-sinusoidal, and that is called as non-linear distortion. And due to non-linear distortion, what happens is we have Fourier series at the output, and Fourier series will have frequency like fundamental, 2f0, 3f0, 4f0 and so on. That is frequencies multiple of fundamental frequency, or you can say new frequencies will be introduced in the output due to non-linear nature of the amplifier. The second one is called as frequency distortion. It is very simple. Remember that we studied frequency response in amplifiers. In both FET amplifier and BJT amplifier, we talked about frequency response. In that, what we saw? We saw that the gain is a function of frequency in both low frequency and the high frequency region. It is not constant. Okay. So, this is low frequency and this is high frequency. This is mid frequency. Okay. So, we have three regions and gain is basically a function of frequency. Okay. Since the gain is a function of frequency, different frequencies will have different gain, and that is called as frequency distortion. That is, the gain is a function of frequency, so different frequencies are amplified by different amount, and that is the case with every amplifier. Why does this happen? It happens due to capacitor or in general reactive components. Reactive components means the components whose value depends on frequency. So whichever component is a function of frequency, like capacitor 1 by omega c, like inductor omega L, that will change the gain based on frequency. So this type of distortion is called as frequency distortion. The third one is called as phase distortion. Okay. Now it is due to unequal phase shift of signals of different frequency. Like we are saying that the gain varies with the frequency, same way the phase shift offered by an amplifier to a signal, that will also vary with the frequency, and that is termed as the phase distortion. So phase distortion is nothing but variation of the phase shift provided by the amplifier with the frequency of the input signal. Out of that, what is most important for our case is nonlinear distortion. Based on nonlinear distortion, what I have told, that harmonics will be generated in the output, or you can say the signal will be non-sinusoidal, due to which it can be expanded as Fourier series. So that means if we have an amplifier with an input voltage Vi and output current suppose IC, then this IC will have DC biasing current. This DC biasing current is IC, plus when we talk about when we talk about output current which is non-sinusoidal, it can be expanded in Fourier series like this. The first term is your DC biasing current and rest is the Fourier series of the AC term, which will continue like this. In this, IC plus B naught is overall DC term. This is due to biasing and this is due to non-linearity. Okay. Plus B1 sin omega t plus B2 sin 2 omega t and so on. Okay. Now out of this, the only desirable term in the output is the fundamental. So we define terms like second harmonic distortion. This second harmonic distortion is nothing but magnitude of B2 by B1. Then we define third harmonic distortion. It is magnitude of B3 by B1. And fourth harmonic B4 by B1, like that. If you want to find out the fundamental AC power, Fundamental is which term? B1 term. So what is fundamental AC power? P1 is amplitude by root 2, B1 by root 2 square into R naught. That is output resistance. B1 square R naught by 2. Okay. Because AC power is always RMS current square into resistance. Okay. Now if you want to find the total harmonic power or total power, what is the total power? The total power or total power AC will be B1 square by 2 R naught plus B2 square by 2 R naught plus B3 square by 2 R naught. When I am talking about AC power, I am ignoring this DC value, which can also be removed by means of a capacitor. So I am only talking about AC. If you take out this term common, the first term, what will remain inside the bracket? 1 plus B2 by B1 square plus B3 by B1 square and so on. This term is P1. This I will call as D2, D3 like this. So it will be 1 plus D2 square plus D3 square and so on. Okay. That means I call it as P1 1 plus D square, where what is this D? This D is the total distortion. D is under root D2 square plus D3 square plus so on. This is called as total harmonic distortion. That is the distortion caused by all the harmonic component is called as total harmonic distortion, THD. Is it fine? So that is your harmonic distortion, and it is arising due to non-linear operation of the amplifier. The next type of distortion is called as crossover distortion. Okay. Now due to crossover distortion, in the characteristic we have a flat zone which is called as dead zone. Dead zone means, what do you mean by dead zone? It is the range of input voltage for which output voltage is 0. That is the range of input voltage over which there is no output produced is called as the dead zone. Now why does it happen? Why does the dead zone happen? See, whenever you want to switch on a transistor, okay, whenever we are switching on a transistor, what we need as VBE? VBE must be 0.7 volt. So for input less than 0.7 volt, BJT remains in cutoff. If BJT remains in cutoff, it cannot work as amplifier. Okay. If it cannot work as amplifier, it will give the output as 0. It will not give any amount of output voltage. That is, for input signals less than 0.7 volt, they cannot be amplified, and that is why whenever input goes below 0.7, suppose this is 0.7, this small voltage is 0.7. In that case, the output will become 0, and that will cause a flat band in the output, and this will be called as crossover distortion. Okay, that means whenever we are crossing the 0 voltage, there is some amount of dead zone on both sides of the 0 voltage, in which the output will come as 0. So the output cannot be purely sinusoidal, and it is called as the crossover distortion. It will be generally seen in case of push-pull amplifier, where we have two BJTs. One is working in the positive region of input voltage and the other is working in the negative region of the input voltage. And both the BJTs cannot be on before 0.7. So this is the region. This is the region where both BJT will be off. Is this point clear? Suppose there are two BJT Q1 and Q2. One is designed to work in the positive region and other in the negative region. Both will be off in the dead zone. None of the BJT will conduct. So even after applying the input voltage, we will not get the output voltage. And that will lead to non-sinusoidal nature of the waveform. And this type of distortion is called as your crossover distortion. So non-sinusoidal nature can be due to two reasons. The first reason is due to non-linear nature or non-linear region of operation, and the second one is due to dead zone in the characteristic, which is called as crossover distortion. In both the cases, the output will be non-sinusoidal, which can be expressed as a Fourier series. Okay, so these are two main type of distortion that are generally experienced in power amplifier. Next, we should talk about thermal runaway in case of power amplifier. We have talked earlier also about thermal runaway. I also called it as second breakdown in BJT. So what did we talk about in thermal runaway? We said that when the heat dissipation is large, then a regenerative process is set up by which temperature of BJT keeps on increasing, and that will cause destruction of BJT. So what we said is, as temperature increases, the reverse saturation current ICO of BJT increases, due to which collector current also increases. Due to this collector current increase, the power in transistor VCE into IC also increases. Due to increase in power dissipation, temperature will increase. So this is a regenerative process. Okay, regenerative process which can damage the transistor. That is called as your thermal runaway. Now since we know that power amplifier are handling large amount of power, so this thermal runaway also becomes more crucial, because if we don't care about the thermal runaway, then my BJT or my power amplifier may be damaged. So how to avoid the thermal runaway? Now we know in BJT when we talk about operating point, we talk about intersection of the load line with the characteristics. So let me draw the load line for the BJT. The load line is plotted on IC versus VCE graph. The load line is a decreasing graph like this. This voltage, this current is your VCC by RC, and this is your VCC. Now we know that power in a transistor is VCE into IC. If I call it as constant, what is the curve in IC and VCE? The curve IC versus VCE is a rectangular hyperbola. So let me draw a few curves, hyperbolic curve, to indicate power dissipation. Okay, suppose these are three curves, 100 milliwatt, 200 milliwatt, 300 milliwatt. So at different powers, I have drawn the curve IC versus VC. Now see, if we see the intersection with the load line, there can be three operating points, Q2, Q, and suppose Q1. There are three operating points. Now what happens is, I told you In order to operate in linear region, I have told in BJT, in order to operate in linear region, BJT is biased at the middle of load line. Okay. We always try to bias BJT at the mid of the load line. That is when VC is VCC by 2. Okay. That is at this point. Now what is the advantage of this point? The advantage is that, now what is the advantage of this point? Before understanding the advantage, first we must talk about the power dissipation. Okay. Now what happens? We know that IC in a transistor is VCC minus VCE by RC. So what is the power dissipation? VCE into IC, which is VCC VCE by RC minus VCE square by RC. If we differentiate this power dissipation with respect to VCE, it will be VCC minus 2 VCE by RC, making it equal to 0. So VCE equal to VCC by 2. That means at mid of the load line, power dissipation is maximum. Your power dissipation will be maximum if you bias at the midpoint. Now you might be thinking that since power dissipation is maximum, we should not bias at the midpoint. But that is wrong. Why? Because if power dissipation increases, then what happens? So what will happen is, if power dissipation increases, IC will increase. If IC increases, then from Q we are moving to Q2. But Q2 lies on a hyperbola having lower power. So lower power. But suppose if operating point is at Q1, so with increase in temperature, ICO increases, IC increases, so we will move towards left or we will move upwards. If we are moving upwards, then from Q1 we are moving towards Q. But Q has power dissipation 200 milliwatt, whereas Q1 has power dissipation 100 milliwatt. So you can say power dissipation is increasing. So if we are biasing at Q, then with increase in temperature, power dissipation is reducing. But if we are biasing at Q1, then with increase in temperature, power dissipation is increasing. So it is always good to bias at mid of the load line, where we can, where with increase in temperature, power dissipation reduces and we can avoid thermal runaway. Because in thermal runaway, what we say, with increase in temperature, power dissipation increases, and if power dissipation increases, the temperature increases further. So we want to avoid that. Okay. Now to understand the condition to avoid thermal runaway, we say that the rate of change of power dissipation with junction temperature is represented by dPd by dTj. It is rate of power dissipation in BJT. Okay, with respect to temperature we are taking. Now in thermal model of BJT, I told you the difference in the junction temperature is equal to theta multiplied by power dissipation. Remember, we represented the thermal model in terms of a circuit where theta was thermal resistance. Okay. In that case, if you differentiate both sides with respect to Tj, 1 minus 0, because ambient temperature is always fixed, is equal to theta into dPd by dTj. So dPd by dTj is how much? It is 1 by theta. Now power dissipation means the power radiated. It is not the power dissipation in the inside BJT. It is power radiated. That is power radiated or heat radiated to the atmosphere. Now rate of heat generation should always be less than equal to rate of heat dissipation. If heat generated is less than the heat radiated to atmosphere, temperature cannot increase. So we say dPc by dTj should be less than dPd by dTj, or dPc by dTj should be less than equal to 1 by theta. Pc is the heat dissipated in the collector region, which is VCE into IC. So the rate at which heat is generated should always be less than the rate at which it is lost to the atmosphere, so that more amount of heat is lost and hence the temperature of the device does not increase. Okay. So if we summarize what we have covered in this video, first I have told you the purpose of power amplifier, that is to amplify large voltage signal, and it must have large power handling capability. Then we saw the major differences between small signal and large signal amplifier. So here we mostly talk about power conversion efficiency rather than the voltage gain. Then we saw different type of distortion, out of which one of the most important was harmonic distortion. Then the second one was, which one? Crossover distortion. These were very important. Harmonic distortion was due to non-linear nature of the device or the circuit. Crossover was due to dead zone due to minimum voltage requirement for turning on. And then we saw the concept of thermal runaway, in which I told we must bias at the middle of load line to avoid thermal runaway, and the second condition should be the rate of power generation or heat generation should be less than equal to 1 by theta, where theta is the thermal resistance. So we have right now studied some basic concept related to all type of power amplifier, but the study of individual amplifier will be carried on from the next lecture onwards. So we will see different type of power amplifier, which I have told you in this lecture, class A, class B, class AB, class C, that we will see in the next lecture. Okay, that will start in the next video, but these are general concept related to all type of power amplifier. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27,225. For 18 months, it will be 34,650, and for 24 months, 39,600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2 year subscription becomes 66600. So the choice is your, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me, and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil, and Telugu, JE channel, Computer Science, Gate Question, and Electrical Junction, Pathshala, and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like, and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon, so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.